Woohoo! All right. So today, ladies and gentlemen, we've got a story and we've got some activities to learn something big and important. I would venture one of the most important things that we're going to do this year. So it's nice that you're here today. I'm glad that you're here. It's cold outside. I don't know if you noticed. And cold weather reminds me of the Winter Olympics. And the Winter Olympics reminds me of my least favorite Winter Olympic sport. And my least favorite Winter Olympic sport reminds me of physics. And so that's how we get back to where we're at. So the first thing we need to talk about is that least favorite Winter Olympic sport of mine. And what do you think it is?
Curling.
Skiing is absolutely not. It's so exciting, right? Especially jumping, because that's like projectile motion. So that's cool. Curling, everybody guesses. I will tell you, I've had this conversation for probably 10 years. And without fail, at least one person says that curling must be my least favorite Winter Olympic sport. And here's the thing. Curling is like my favorite Winter Olympic sport, maybe like second or third favorite. If you've never seen curling, it's so cool. So curling uses these big stones. They're like this big, and they slide them on ice. Like, what more exciting thing could you have? Not only do they do that, but they use friction, and that's why it's great, right? They use those little brooms, and they increase the friction on the ice to like slow down the stone, or to make it literally curl, to make it turn. It's very exciting. It's like, shuffleboard on ice. I don't know. I think it's exciting. Anyway, curling is not my least favorite Winter Olympic sport. Any other good guesses? Any other? Ice skating is close. So here's the thing about ice skating is that it's exciting, right? Because people can jump, and when there is jumping, there is, there is opportunity for disaster, right? When in pairs figure skating, when you have one partner who can throw the other one, that's exciting because you've got projectile motion going on. You've also got spinning going on. You've also got opportunity for disaster, right? So that's exciting as well.
Speed skating.
Speed skating is pretty cool in that it just, is really fast. My least favorite, I'm going to tell you right now, my least favorite Winter Olympic sport, it's related to ice skating. And in fact, many people don't realize that they're different sports. But my least favorite Winter Olympic sport is ice dancing. And so, right, a lot of you are like, what's that? Let me tell you why I'm not a fan of ice dancing. There are a few reasons. And I want to put the caveat out there that I don't ice skate. And so any of you could probably ice dance circles around me, and I wouldn't it's not like I think it's like not a sport. I just don't enjoy it nearly as much as figure skating. So ice dancing, in my understanding, and I have not done a lot of research, but I've just, watched the Winter Olympics, and that's where I see this. Ice dancing is always a pair sport, which is fine, okay? The problem with ice dancing is, in my understanding, both partners, have to have at least one skate on the ice at all times. The trouble with that is that they can't do triple jumps, right? And they can't throw each other, and those are the most exciting parts of figure skating. So that's my big reason that I don't love it. The other reason that I don't love ice dancing is because it's really, really cheesy. And it's really, really sappy a lot of the time. So it's always like these really froofy dresses, okay? And always this like super like cheesy romantic-y music. And I'm like, not so much. Like, that's not my bag, okay? Mm-hmm. And the thing about ice dancing is that I want to say about 90% of ice dancing performances start off the exact same way. They start off exactly the same way. Sam, stand up. You're gonna come ice dance with me. All right. So this is exactly how they start. Okay. So there's one partner and there's another partner, and they stand like this. Okay. And they gaze into each other's eyes. Right. That's the part I don't really like. So they gaze into each other's eyes, and then the music starts. And then what do?
Push.
They push. Right. Okay. That was very nice. Well done. Nice job. You can sit down now. I'll probably get up in a minute again. So they do this ice dancing goofiness, and that's where I really want to look at, because even though it's really cheesy, and even though it's really, it does have good physics in it. And that's the part that I want to look at. So Sam's going to stand up here again one more time because she did a really good job. And you're going to stand like that as if I was standing next to you. Right? Okay, so we'll get you ready. So she's like this. Now, I would like you to draw a free body diagram of Sam. So could you draw a free body diagram of Sam? Sam, what's your favorite color?
Green.
Green. Awesome. Thanks.
No, it's not.
You're lying?
No, I don't have a favorite color.
Oh, okay. You're gonna claim green for the day.
Yep.
Awesome. All right. So I'm gonna draw a picture of Sam. There she is. And you're gonna draw a picture of Sam on your paper too, and you're gonna draw a free body diagram. So you're gonna stand there. Okay, as if you're ready. The music is about to start. Okay, draw a free body diagram of Sam. What forces are acting on Sam? Talk to your table mates if you need to. Figure it out. What forces have you got? How many forces do you have?
That was funny. You're gonna make a wheel over there.
It's okay. It's all right. All right. Lily, what's one of the forces you have?
Force of gravity.
Force of gravity, also known as the force of the earth. And which way does that one pull or push? Down. It's like we've done this before, right? You know this. Force of the earth on Sam. There it is. All right. What other forces you got? Yeah.
Force of the surface.
Force of the surface. In this case, what surface is she standing on? The ice, because right, we're imagining this is happening, right? She's standing on ice, and where's the ice pushing or pulling on her? Up, right? Life is good. All right. Force of the ice on Sam. Awesome. All right, so there's Sam. That's awesome. Now, I'm going to put myself, my favorite color is orange. It looks nice because we got the orange, we got the green. It's awesome. All right. So now, Sam, you can sit down for a second if you want. You can draw your self-portrait. And then you're going to draw a free body diagram of me. What forces are acting on me? Same forces, right? Same forces. We've done this a bunch of times. You know this. Force of the earth on Miss K. And the force of the ice on Miss K. All right. What's the net force acting on me? Is there a net force or is the net force zero? It's zero, right? Yeah, it's zero. How about on Sam? Zero. All right. Now I'm not going to make Sam get up again, but I'm going to have you imagine. So we're going to stand here, okay? And the music is going to start, and we're going to push. Are you with me there? Okay? We're going to push. So now I need you to draw those forces. So first of all, who's pushing? Let me ask that question first. Who's pushing? Both, right? I'm pushing on Sam. Do you agree? So draw that force. The force of Miss K on Sam. Which way does that one pull or push? To the left. Does that make sense? Yeah. Okay. And what happens at the same time? Oh. Does Sam push on me? Sure. Which way does she push on me? To the right. Life is okay? All right. I've got a few questions to ask you about this. First of all, are we okay with this? Is this making sense? Okay. So I want to know, does Sam accelerate? Does Miss K accelerate? I want to know, put it in the middle here, who pushes first and who pushes harder? So there are 4 questions there. I want you to talk to your table mates. 1, 2, 3, 4. Take a look at those 4 questions. Talk to your table mates. See where you're at. You have to talk, you guys. Come on now. You got this.
So the one that goes like so the one that goes so the whoever goes farther
I guess whoever's further out without first time.
is like they go pushing to the same side. Not necessarily. Well, no, because if the person pushes first, then they would both be gone apart from each other. So that would mean
You guys answer your questions?
hard to do.
No.
Right? Because they apply the first force.
You've got lots of space. You can write
And then
Josie's
you,
answer,
like,
and then you
because
can
the
write
ice would be like
any correction. Okay, Josie's answer, and then you got that. Or you can split it in half. You got this. I'm gonna not point out the person, but I'm gonna address and say, ladies and gentlemen, I want you to write down an answer. Commit to something. It's okay if you have the wrong answer written on your paper. You've got lots of paper and you can write extra answers. You don't need to erase. Okay? Learning is a process. We embrace the process, right? Okay? Learning is a process and I want you to do it, which means you've got to commit to something. Write down an answer for each of those 4 questions. Jacob, did you have a question today?
Yeah.
What's up? Yes, of course.
Because aren't anything really accelerating? Like, yeah.
Why is that rude? Because you're saying that you have more math than you. Math is a quantity, and we're not making any judgments, right? Like I have more math than my kids. I'm not saying that. That doesn't mean I'm saying, right? Does that
What do you mean?
sense?
Mine is
Some people have more math.
Unless there is no friction.
She's saying if what you're saying is what you want to commit to, you're saying. All right. Did you commit to some answers? Does everybody have something written down? I'm not saying it has to be right or wrong. I just want you to commit to something. Did you write something down? Yeah? Okay. Now, I was having a conversation in the back of the room that is an important one to have about about this situation in our conversation. Now, Sam, I want you to come stand up here one more time. Okay? And I want you to just compare our sizes, relative sizes. Okay? Which one of us is bigger? It's not me, right? Okay? We're not making any judgments or comments or anything. I'm going to venture, given that you're much taller than me, that you probably have more mass than me. Are you comfortable saying that?
Yes.
All right. There's no judgment. There's no problem with that. I just want to make that clear because this is not like a body shaming. Like you literally are just a bigger person than like little me, right? So like that's just the scenario. So I just want to make that clear. So we are stating, for the record, that Sam has more mass than Miss Carbeling because she's not even 5 feet tall. So there you go, right? Like it's just true. So there you go. Okay, so now that we've got that out in the open, question 1. Does Sam accelerate when the music starts and we push?
Yeah.
What'd you say, yes or no?
Yes.
Yes. Okay. Now, do you think I'm just going to leave that as a yes or no question? Of course not. What evidence do you have to say that Sam accelerates?
She was stopped and now she's
Yeah, she has a change in velocity, right? And acceleration is equal to change in velocity over time. So for sure, she does accelerate because her velocity changes. She was at rest, and now she is no longer at rest. Awesome. I have another follow-up question because that's just how I roll, right? So absolutely, Sam accelerates. Absolutely, her velocity changes. Can you look at this free body diagram about Sam and give me another reason that you know that she accelerates? Yeah.
There's only one arrow in the X direction, so the F net can't be 0.
Right, absolutely. So 2 reasons that we know that this is true. F net in the X direction does not equal 0. And if F net in the X direction doesn't equal 0, we know that the acceleration in the X direction can't equal 0 as well. So boom, we got 2 reasons that we know that it's true. Look at all that physics. It's so good. All right. Question number 2. Does Miss K accelerate? How do you know?
Because you're changing velocity.
Absolutely. My velocity is changing as well. I have a change in velocity, which means I accelerate. My F net in the x direction does not equal 0. Net in the x direction does not equal 0, which means my acceleration does not equal 0. Awesome. Okay. So we know that there's an acceleration. That's exciting. What did you decide about question number 3? This is a very lucrative question, ladies and gentlemen. I want you to know that. Lucrative, do you know what that means? Like useful, helpful, just putting that out there. Who pushes first? Come here, Sam. Let's do it. It's exciting. Get up, down, up, down, up, down, down. All right, here we go. We're not on ice, so we're not going to see the same thing. But if I start to push, what happens to you? You move. And what else do you do? She pushes. Right? Does that make sense? That was awesome. That was all I needed to do. I just need like that thing there, right? Who pushes first? What's that? I heard somebody say something over here.
You both push first?
A force, I want to remind you this, we said this a while ago. A force is an interaction between how many objects? 2. How many objects have to be involved? And so anytime there's a force, the force between Sam and Miss K, there have to be 2 objects involved. That means both objects have to be pushing. Okay? So who pushes first? Nobody. Is kind of not a trick question, just a thinker question, right? No one is the answer there. Nobody. We push at the same time. So the forces start at the same time. Now, I told you this was lucrative. The reason that I think it's lucrative, that I think it's helpful, if you have siblings, for example, that you happen to bicker with, or maybe this is like less useful for you these days, but maybe when you were a little kid, okay? Now, I don't have any siblings, so this never happened to me, but I imagine that siblings bicker sometimes, and sometimes they start, pushing and da-da-da. And I've heard, because I have cousins that do this all the time, right? Like, she pushed me! She pushed me first. You see where I'm going with this? Yeah. So if I push on Lily, she's pushing me at the same time. So that whole argument of she pushed me first is out the window. Are you with me there? Yeah. I'm not saying that you can get away with stuff now. I'm just saying you can use physics to make arguments more effective. Are you understanding what I'm saying here? Yes, yes. My poor children have to deal with this from the beginning, so that's just going to be rough for them, right? What's that?
I was just about to ask, are you one of those parents who's like, no, that's technically not right?
Oh my gosh. Don't even, oh yes, oh yes. We talk about the coefficient of friction a lot at our house. Oh yes, oh yes. My poor kids, it's a rough go for them. All right. Yeah. My daughter today on the way to school was like, look, that snow is so pretty, it sparkles. I was like, do you know why it sparkles? Do you want to know what she said? She's like, physics. Got it. Then we talked about why, but anyway, it was pretty fun. All right, so there you go. It's gonna be a rough go for them. All right. Who pushes harder? That was the 4th question. Question number 4. Who pushes harder? Yeah.
Is it the person with the less mass?
Person with the less mass. Why do you say? I'm going to write that down just to make sure that I'm following your train of thought here. Less mass. Why do you say?
Because if you're trying to push Sam, obviously she has more mass than you, so you have to push a little bit harder to kind of equal out, I guess. You know what I'm trying to say? Push. I don't know what I'm trying to say.
I kind of understand what you're trying to say. What do you guys think? Do you agree?
Sounds right.
Yeah. Jacob, was that what you were arguing, or were you arguing the other thing?
I was arguing that.
What's that?
I was arguing the same thing.
You were saying the same thing? So you're saying the person with less mass needs to push harder. Okay. Question for you. Let's imagine, I don't have an ice rink here, and So we can't really see this, but let's imagine, and let's scale this up a little bit because Sam and I are different masses, but let's imagine somebody like much more massive. I don't know, somebody really big, right? And then like little me, right? Imagine what's gonna happen. So we stand there and then we push. Am I going to accelerate? Where am I gonna go? Bing, right? You know I am. Woo, there I go. What's gonna happen to the other person? The person with much more mass. Are they going to accelerate?
Yes.
Yes, because they have a net force on them, right? So absolutely they're going to accelerate. Yeah. Now I go thinking like that, and the other person just goes. Doesn't it seem like maybe that person has to push really hard on me to get me to fly backwards? I don't skate well, so literally I'm just going to keep going until I hit the wall. Like it's going to be a bad news situation. And that person's really big. And that means they're really, really strong, right? Do they push harder on me?
Push the same amount, but then max.
So you said something with a question mark at the end of your statement. I want you to flip it around, and I want you to say it with a period at the end of your statement and sound confident. Say it again.
You push with the same force, but because you have different masses, it affects you differently.
So we have different what?
Accelerations.
Accelerations. It's weird to think about. It's weird to think about that I'm going to fly that way, and the other person will go from the same force. But can you see a force? Do you see that interaction? Really, the thing you see is a change in velocity. Are you with me there? You see that Miss Carveling was sitting there like this at rest, and then all of a sudden she's going that way really fast. The thing that your eyes see and that your brain processes, you see, write this down here, we see acceleration. Right? We see acceleration, and the acceleration is dependent on the force and the mass. Okay? We see the acceleration A, which is dependent on the force, the net force acting in a certain direction, divided by the mass. It's weird to think about. It's not intuitive, but in fact, the force that Sam applies to me and the force that I apply to Sam are exactly the same. Oops, I was trying to make that just a little bit smaller. There we go. The force that Sam applies to me and the force that I apply to her are exactly the same in magnitude. Okay? It's hard to believe that sometimes because the result isn't the same. Because I fly backwards and she just goes that way a little, she just keeps going that way, but very slowly. But it's because the acceleration is the thing that we're watching. Okay? Yeah.
So if like two people are the same exact mass, they'd accelerate at the same speed.
That's exactly right. Yes. Yes. I'm going to write that down even. Yes. If you have two people or objects, doesn't matter if they're people or not, with the same mass, and they interact, they will have the same acceleration. Absolutely. All right. We doing okay? Everybody happy? Yeah? All right. Cool. We've got time. We're going to do the next thing. All right. You can put your pencils down. You're going to leave that stuff there. We're going to take some more notes in just a couple minutes. But right now, I'm going to ask you to take a little green card from you and come around to your table. Grab one. Pick a card, any card. Pick a card, any card. Did you go there? There you go. 1, 2, 3. Pick a card, any card. 1, 2, 3, 4. Oops, I just dropped 2. All right. No. Really? Jeez. All right. So, we said earlier today, but we didn't write it down. I'm going to write it down right now. That every force, we're going to write this down. I want you to write it down too. Again, every force is an interaction between how many objects? 2 objects. Okay. We would say that, so in this case, we've got 3 different objects that are acting on me. The ice is acting on me, the earth is acting on me, and Sam is acting on me, right? At the same moment that Sam pushes on me, though, what do I do to her? What do? I push on her too, right? It's an interaction between 2 objects. That interaction between 2 objects leads to what I call a force pair. Forces always come in pairs. Okay? Your little green piece of paper, your little green card that you have, has a force on it. Your goal right now is to find your force pair. Okay? You need to get up. You need to talk to people. You need to figure out what your force pair is. Let me give you an example. The force pair, if my force said force of Miss K on Sam, I'm looking for the person whose pair says what?
Sam on Miss K.
Sam on Miss K. All right? Go.
What's the bowling ball?
You're going to have to get up. You're going to have to talk. Once you find your partner, then find a spot to sit. No. So I've got the force of Miss K on Sam. I'm looking for the person that has force of Sam on Miss K.
So it's just the opposite?
Got it. Are you guys buddies?
I don't know.
Frog on table? That's frog on table. So what are you looking for?
I'm looking for the.
You guys fair? Good.
Wait, are you?
How did that happen? I guess you gave us some probability, right?
Is there force?
What's a bowling ball on Earth?
Okay,
Oh, I
that's
got the force of the earth on
Forces
the
come
front.
in force?
What?
Well,
Are you a bowling ball?
no, they come in what? They come in pairs. Find your pair.
We both have the same one.
And no one
Would that
else
not
has
be-
the opposite one of ours. We both are bowling ball on Earth.
Well, I'll switch yours. So you guys be a pair. Yeah, you're good. Did I mess something up here? Or did somebody else mess something up? All right, let's go around and make sure we're good. You guys can sit for just a second. All right, Jacob, tell us what you got. Gotta say it loud so everybody can hear you. Go.
Force of table on Earth.
Force of a fun table.
All right.
Force of string on balloon.
Who's your partner? Who's your pair? Okay, say it.
Force of string on balloon.
Okay.
Force of balloon of string.
Okay.
Force of balloon on Earth.
Force of fun balloon.
Okay. So those sound like pairs. Yeah? Let's keep going.
Force of string. Force of table.
Okay. So you guys are not a pair. Does that make sense? Did you hear like the pattern that's happening? Yeah? Yeah? Okay. So I think there's some resetting that needs to happen over here. So I'm going to give you another 30 seconds. If the pattern that you've heard is not what you said, what you have, then find your partner. So I think we're missing a couple pairs, right? Like you guys need to find your buddies. Yeah. Yeah. Find your buddies. There you go. Yay, buddies happen. It's a beautiful thing. Da-da-da-da-da-da-da-da. Go Fire! Spring disappear also? How did that happen? You are or you're not? Oh, funny. Okay, so Dasha, tell me what you are.
Force of bowling pin and bowling ball.
Bowling pin and bowling ball?
Force of bowling ball and bowling pin.
Bowling ball and bowling pin. I just want to do ball and pin, but it didn't make sense. Go, yeah.
Force of bug on car.
Okay.
Force of car on the.
Okay.
Force of earth on bowling ball.
Force of bowling ball on earth.
Okay.
Force of earth on bug. Force of bug on earth.
Okay.
Force of bowling on bowling pin.
The force of bowling pin on ring.
Okay.
Force of table on bug.
Force of frog on table.
Awesome.
Force of frog on earth.
Force of fraud on earth.
Okay, so I don't know what happened there. Yeah, so you guys are going to be.
Or force of earth on.
Okay, good. Yay, good. I only made one mistake. Yes, that's awesome. Sometimes that happens. All right, so now I want you to think about what you just heard. So there are 4 stories that I think we have in there, right? There's one about a bowling ball and a lane and a bowling pins and stuff like that. There was one story about a table and a frog. So there was a table and a frog story. There was a balloon and a string story. And there was a bug and a car story. Okay? So I want you to just think about those stories. I want you to talk to your pair. And if you're kind of in this mix, I want you to separate so that you're just talking to your person, to your pair. I want you to talk to your pair, and I want you to figure out in your pair which force is bigger. Okay? Go, have a conversation. Move around so you're sitting just with your person. Which force is bigger?
Always carries the
Which force is bigger?
Wait, Mr. K, is the one with the small? Bigger than two.
What's that?
The one with the small.
I don't know. What did we talk about? What did we decide? All right. You've had enough talking time. I would like for you to stand up if your force is bigger. Stand up. If your force is bigger of the two, stand up.
I don't know. I hope it is.
I'm feeling
If your force is bigger, I want you to stand up.
what? We think pretty cool.
Oh, wait, what? Why?
Oh, because we said.
Oh, because it's not moving?
Oh, well.
So, okay, which situation are you doing? No. We did, so talk loudly. What?
My direction.
No.
Bowling ball's on one.
Who's pulling harder? What do you have? You have the hand on the string and the string on the hand. Who's pulling harder? Come here, Sam. We're going to imagine that Sam is 3 times bigger than Sam is. She's a very large Sam today. What are you doing? No. Oh, okay. I see. I was like, what are you doing? All right. And here we are. And the music's going to start, and we're going to push. And she's not on a stool, so she's going to go backwards, and I'm going to go backwards. Who pushes harder, you guys? I pushed harder?
No.
It's the same.
Who pushes harder? It's the same. Why do we think that or that she's gonna push harder than I'm gonna push harder? What do we see?
Acceleration.
Faster.
You see me accelerate, right? Which either means that she's super strong or that I'm super strong. I don't know. But it's the acceleration that's the thing we care about, right? So how many people should be standing up in this room right now?
0.
Well, me, I guess, because I don't have a partner. But yes, everybody else. Nobody should be standing up, right? You need to be sitting down. You need to be sitting down. I want you to keep that in your brain. Hold on. I want you to keep that in your brain. That's super important. we're not at our tables right this second, so we can't write this down, but I want you to keep it in your head. Anytime you have a force pair, I'm going to write it down here so we can look at it later. Forces always come in pairs, and their magnitude, what does magnitude mean? Their magnitude or size of the pair is always the same. The thing that's not the same is what? Their accelerations may not be if their masses are different. All right. Now, we've got just a couple minutes. This is what I need you to do listen very carefully. I need you to get with your story partners. So if you are the bowling ball people, you're going to sit together, and all of the bug people are going to sit together, and all of the balloon people are going to sit together, and all of the, what am I missing? Frog people are going to sit together. Get in a spot with all of your people. Go, 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 go.
Those two people are
Find the story that belongs to you. Find the story that belongs to you. Are you guys a story?
Yeah.
Which story are you?
The bug and the car.
The bug in the car? What you draw, using your pairs, I want you to draw a body diagram of the bug. Okay? Are you guys a what story are we? I think, does one of them have answers? Maybe it's the bowling. Is that right? Yeah, so I want you to draw a free body diagram of the bowling.
Table.
Okay? What are you guys looking for? Frog. Are you guys a frog story? Table and frog and stuff?
Table and
Come on over.
earth. Oh, I told you,
You
Lily.
guys are here. Okay. Okay. Everybody diagram of the frog. And you guys are my balloon friends?
Yes.
Everybody diagram of the balloon. Go. Free body diagram of the object in question. Tell the story.
Alright.
I trust you.
Okay.
Just
Just these things. What things are acting? What's acting on the bug? Help each other out. It says the force of the bowling ball.
So is the earth right here? This is the earth.
Yeah, they're actually. You know the happy birthday ones?
So the bowling ball is affecting the bowling. Show me the box.
Okay. So,
I guess we have like the force of the earth and we have the force of the earth on the bug right now. But then that bug. How do you do that?
That's why I'm asking you. Make sure the car's acting on the bug too.
Yeah.
I'm just going. Yeah.
Table on frog.
All I want is a balloon.
What's going on?
Talk to each other and work together. Even if there are 6 of you, you guys can talk as a 6. A group of 6.
Well, if it says
Six.
is it in the car or is it on
How do you know this?
It's gonna hit the windshield of the car.
Splat.
Splat. Splat. That's wrong? I mean, it's kind of like a car. All right. How we doing? We got our pictures?
So then wouldn't the force of the bug
So that'd be the force of the table.
Or am I saying that wrong?
Yes.
It's different.
Yeah, because if it's gonna splat.
I'm not gonna tell you, I'm just gonna ask every time.
Yeah, so sure.
Yeah, so that's one for the car and one for
That's
the
where the force of the bug. Yeah, so change that to the force.
Yeah.
Sorry. You're
Are you ready?
really close. No, force of yeah. Wait, so what is this? No, force of the bug.
Right?
Force of the bug. And then the bug's in the
I'll come back.
or whatever it was.
What?
What's your force?
I did. What was it? You remember?
Remember?
Who was your partner? You guys can remember.
Half of it is about the string, not the balloon.
Right, I don't
You
care.
said don't work, you said don't work string.
Right.
Because
I know.
So that takes
I know,
away.
I got it, it's fine. Only forces that were in the pair should be part of your story though.
Force of balloon.
yeah, I think both of them are. Yeah.
That's not.
Force of. So ours was force of string on balloon. Force of balloon on-
I've learned from my mistakes.
All right,
Sorry.
before you go, ladies and gentlemen, I need your pictures. We're gonna start with the pictures tomorrow. Before you go, make sure that you write this down. Make sure you write this down. That's important. The magnitude of those forces in the pair, is always the same. That was impressive. It's all good.
Maybe we should
Hold on.
come over and I can try to practice on the
So, with this cardboard,
Yeah.
when you,
And then we
when
can
the
send
point
you
is
yours.
just the
No.
keep going and then
It's sensitive to Ivy.
We'll talk to you tomorrow. Thank you guys I want you to do this homework. Yes, you can do this. That's why I gave it to you. Yep, we will start by talking about it tomorrow.